Here's another GCSE exam style question. So it's a slightly trickier question, I would say, compared to some of the GCSE questions that are pretty straightforward. But it's not too difficult, but there are certain calculations you need to be, so you need to be careful with that. So I would like you to give it a try first, and I will talk you through the answer in a bit. A metal filament lamp is connected to a 12-volt battery. So I know the EMF of the battery is 12. So that is the value of capital R. The lamp is switched on for 15 minutes. So the time is 15 multiplied by 60, which is 900 in seconds, 900 seconds. However, due to heating, the resistance increases by 20% after 5 minutes. So when you start it, it's 24. After 5 minutes, it goes up by 20%. Part A. Calculate the initial current through the lamp, I. So I know the V, I know the R. So obviously, first part, V is equal to IR. Now voltage is 12. I don't know I. R is 24. So all I need to do is divide both sides by 24. 24. Cross these two out. So I can see the current is 12 divided by 24 is 0.5 amps. So the answer to the first question is 0.5 amps. Second one. Calculate the power output during the first 5 minutes. So in the first 5 minutes, the resistance stays the same. Oh, so I know the formula. I have to use one with V and R to get power. So power is equal to V squared over R. Part C. Calculate the new resistance after 5 minutes. Now we know after 5 minutes it increases by 20%. So all I need to do is 24 multiplied by 20% is 120 over 100, which is 1.2. So this is the multiplier in maths. 20% on top, that's 120, 120%. 120% is 120 over 100. That's multiplying by 1.2. Calculate the current for the remaining 10 minutes using the new resistance. Now, the new resistance is 28.8 ohms. However, the value of V is still 12. That does not change. So obviously, what we need to do is write V is equal to IR. 0.416 recurring. So maybe we can round it approximately to 0.42 amps. This is the new current. Now let's have a look at the last part, part E. Calculate the total energy transferred over the full 15 minutes. Now, this part is a little tricky because the power is different in the first 5 minutes and it's different in the next 10 minutes. So what you need to do is split up this. Let me show this in a small diagram so that it makes sense. So here you can see the first 5 minutes. And in that time, we know the power because part B did exactly that. The power during the first 5 minutes is 6 watts. So the power is 6 capital W. Then for the second part, so for the second 10 minutes, we know the new resistance is 28.8 from here. The voltage still remains at 12 volts. So to get the power, I can simply use the equation V squared over R, and now my V is still 12 squared divided by 28.8. And this gives me the new power as 5 watts. So for the first part, it's 6 watts. 5 minutes is 5 times 60. That's 300 seconds. So multiply this one by 300. That's 1,800 joules. Now 5 times 600 gives you 3,000 joules. Now you can see it's 1,800 joules in the first 5 minutes, 3,000 joules in the next 10 minutes. The total energy transferred over the full 15 minutes is simply the sum of the two. 3000 at 1800. Final answer 4800 joules.